session, in the previous session to this, I discussed about the behavior of switch, how actually the switch behaves, and the default behavior of the switch. So I hope you will get those recordings once you join the class. You might get those recordings as well, accessible to you. Today, what we are going to speak about is, we will talk about, there is an important protocol, right? So in the switches, so you know that we are talking about CCNP ENCOR, right? We are here to discuss about the concepts in CCNP ENCOR. For those who did not join the last session, we will be discussing about CCNP ENCOR. In the last session, I have also written down all the syllabus that belongs to CCNP ENCOR. Now, the first topic is all about switching. Now, since you guys already have been through CCNA and come here to CCNP ENCOR through your CCNA, would also be knowing what is switching, what is a switch. You would all be knowing all these concepts, right? Switching is all about how the switch behaves, or what does a switch do whenever there is a packet entering to it. What does a switch do, right? In the previous session, I told you the switch maintains a table called as MAC address table. This is the brain of the switch. In this particular table, it will maintain the MAC address of the sending device and the destination, and it will map it to the port numbers. So for example, computer is sending any data. Let's say the data is 1010. Just to reiterate the previous session, right? Because most of you were not present. Let's say the data that the computer has sent is 1010. Now, you know that the computer or any network device which is sending the data always will follow the OSI model. Data is nothing but your layer 1. On the layer 2, it will add its MAC address, sender's MAC address, and receiver's MAC address. So this is the source MAC, this is the destination MAC. Together, it is called as a layer 2 header. Why it will add layer 2 header? Because if there is only data, that data does not know to which computer I have to go. That is the reason the computers will add the headers. And after the layer 2 header, what is added? Of course, the layer 3 header is added. In the layer 3 header, what else I can find? In the layer 3 header, you can find source IP address, destination IP address. I am not saying that this is the only thing that you will find in the layer 3 header. And this is the only thing that you will find in the layer 2 header. There are more things that you will find in these headers. But this is something to explain the concept. I'm only taking these into consideration. Whenever PC or a computer sends any data to the switch, let's say this is the packet, and the packet, I write the information or a packet in this way. Now this packet consists of the data also and the header also, that is from and to address. What does your headers have? Headers will have from and to address. From MAC address to MAC address. From source IP address, from to destination IP address. Whenever it reaches the switch will see from where is this packet coming from? Who is the source? Switch can only read layer 2. So it will come to know that on my port number 1, somebody called AA is connected to me. And when it has to send to somebody called BB, it will broadcast. Why? Because it doesn't have an entry for BB in the MAC address table. But if we assume that BB, there is an entry for BB in the MAC address table, switch will check where does this information want to go. It wants to go to BB. Do I have information for BB? Yes, I do have. It is on port number 2. Switch will directly send it to port number 2. Now, this is how usually switching happens. Switching means the information coming to one port is sent on the other port. That is nothing but your switching. What is routing? Suppose there is a router. Information is coming on one port of the router. It checks its routing table. And then, according to the routing table, it will select on which port I have to send out this data. Either this port or this port. That is called as routing. Right? So, switching and routing. Switch depends upon the MAC address table. Why? Because I have received something. Where should I send it out? MAC address table will help the switch. Routing table will help the router to send the data received on one interface to go out on another interface. This is the concept of switching or the switches. Yesterday I have told you about what is a broadcast that the switch do. What is a unicast communication inside the switch. All these have been explained. Today, one of the most important protocols that we have for communication, we will be discussing that. Okay, that is known as ARP. Address Resolution Protocol. Address Resolution Protocol. Now, this is a very important protocol. I'll tell you why. Now, let's assume there are two computers connected, or a computer and a server is connected. Let's say this is 1111 with an IP with a MAC address of AA. And this is 1112 with a MAC address of BB. Now let's say they are connected, the computer and the server is connected to the same switch. Now a lot of you would know what is a MAC address. Basically, what is a MAC address? MAC address, you find a port here, right? You have a cable. You connect the cable from your computer, or you connect a cable on the port of this computer. Now, just behind that port, this is a port or this is a port. Usually you will have RJ45 ports here or USB ports here. You connect the cable here, Ethernet cable. Behind that port, you will have something called as a NIC card or Network Interface Card. We call it as NIC. Now, this is a card, NIC card. This is the one which is responsible for your network communication. It helps to send the data, receive the data, process the data. Now, all your networking devices, routers, switches, servers, firewalls, mobiles, everything, they are able to communicate to other device. They are able to talk from one device to another. This is with the help of this network interface card. If there is no network interface card, then they cannot communicate. Obviously, because there is no network interface card. So, once you see any device talking to another device, it means that both have network interface cards inside it. Okay? Your sofas. Let's say your sofa. You're sitting on a sofa. Is your sofa able to communicate with another sofa? No. Why? Because it does not have a network interface card. As simple as that. I know that is the worst example, but yes. Right? It does not have a network interface card, so it does not communicate with anybody else. As simple as that. Now, what does this network interface card have? Now, inside this network interface card, there will be an address. That is called your MAC address. That is called as your MAC address. Every computers, every servers behind the port that you are connecting, where you are connecting your cable to, behind that port, there is a network interface card on all the devices. And on that network interface card, you have a physical address or a MAC address. That is why MAC address is always called as physical address or hardware address. They use different names for the MAC address. Why it is called as a hardware address? Because see, it is physically present. This address is physically present on that network interface card. Now this computer knows what is the address on this card. So whenever it generates any data, it will add inside that data, before sending the data to the switch, there is some rules and regulations. What are rules and regulations? Before any device sends any data.
To interrupt.
Yeah, sure, go ahead.
𝗖𝗵, Vivo and Vivo X100. Please join with your name, guys. थोड़ा सा काउंसलर के लिए प्रॉब्लम हो जाएगा नाम ढूंढना, ठीक है? आप लोग जो भी आपका नाम है आप बता दो, आप मैं रीनेम कर देता हूँ या फिर आप खुद से रीनेम कर लो. इट्स Vivo X100 and 𝗖𝗵.
Okay. Guys, you are showing up in the Zoom meeting as Vivo 2443, Vivo X100 and 𝗖𝗍. So it would be great if you can tell your names out so that it will be easy for us.
कैलाश विश्वकर्मा है. Vivo
Your name is
X100.
Okay,
Yes,
your
yes,
name is Kailash?
yes.
विश्वकर्मा.
Yes, please let me rename you Kailash.
हाँ, कैलाश विश्वकर्मा.
Kailash Vishwakarma. Okay. What
Thank you,
about
Kailash.
Hello.
Yes. Thank you for that,
Thank you,
Kailash.
Kailash. It's 𝗖𝗵.
𝗖𝗵 में वो होगा जतिन होगा. जतिन बता देगा वो.
Okay. Let me rename Jatin.
Jatin, are you joined through a 𝗖𝗍 device?
जी सर.
Okay, thank you, Jatin. Yes.
What about the other one with Oppo? Somebody has joined through Oppo phone.
आकाश यादव. आकाश यादव.
Akash Yadav.
Let me rename.
Thank you, guys. I think Akash Yadav is already there.
Two Akash is there. Akash Yadav and Akash Yadav.
Two Akash is there and one Oppo is also there. Okay.
सर मेरा ऊपर ही दिख रहा है आकाश यादव.
अच्छा.
तो आकाश आप वो नहीं ना हो जो दूसरे आकाश शो कर रहे हैं, आप अलग हो ना?
नहीं ओप्पो नहीं है सर.
Okay. Let me rename you only Akash. Let me remove Yadav.
Yes.
Thank you, Akash. No, sir, you can continue. Thank you.
Okay. All right. Now, once after we knowing about the MAC addresses, once we know about the MAC address, now I told you before a computer generates any data, it is not allowed to send the data as it is. You know that the computers or any electronic gadgets, any electronic devices, they generate the information in the binary format. What is binary? Ones and zeros. You know it. You know it already. So they generate information in the form of ones and zeros. Once they generate the information, once this computer generates this information, it is not allowed to send the data as it is. It is a rule made by OSI model. So what should it do? If it is not allowed to send the data, whatever it generated, it is not allowed to send this data, just 1010 to the switch. How should it send this data? Along with the data, it should add the headers. It should add the headers along with the data. What all the headers the computer should add? Layer 2 header, layer 3 header, layer 4 header. These 3 headers the computer should add along with the data, and then only it is allowed to send to the switch. So the computer which generated the data, all the computers in this world, the manufacturer would be aware of all these. They design their computers or devices in such a way that once after generating the data, it will add all these headers. So every network device will add this. So this computer in the layer 2 header, let's say layer 2 header is from here to here, from here to here. In the layer 2 header, it will add the source MAC address, which is the MAC address or the address of this network interface card. Right? It will add the address of this network interface card. So let's say it is A. Now we will come to this address. Does it know about this server's MAC address? It won't know. It won't know. I'll tell you why. The IP address of this computer is 1111. So in the layer 3 header, the computer will add source IP and destination IP. Now here we will talk about these headers now. Now, how does the computer know its address? Obviously, because it is configured on this interface, obviously it will know. Now, for example, if I go to my computer, command prompt, and say ipconfig, see, my computer knows its own IP address. It knows its IP address. I don't have to tell it. So it will add its IP address in the source IP field. There will be different fields in the layer 3 header. In the source IP field, it will add its IP address. In the destination IP, how does it know the destination IP address? Because of the user who is sitting behind it. Let's say Akash is sitting on this computer, Sridhar is sitting on this computer. Now, once I go to Google, right? Once I go to Google, what will I type here? Maybe I'll type some address 8.8.8.8, or I will say google.com. Now, whatever the IP address that I type here, this is where I want to go to. Do you guys agree? This becomes the destination IP address. If I want to go to Google from this my computer, then Google is the destination. Google.com is converted to IP address. That IP address will be entered here in the destination IP field. But let's say this server is 1112. So I will enter 1.1.1.2 here. Right? I'll enter 1.1.1.2. So this destination IP is 1.1.1.2. So one thing is clear. The computer always will know source IP and destination IP for sure. Why? Because the user sitting in behind the computer will enter the address maybe in the browser or through an application. He wants to go to a particular destination like Instagram, Facebook, whatever. that IP will be entered here. So source and destination fields, we don't have to worry. Now let's talk about MAC address. Right? Let's talk about MAC address, that is layer 2 header. Now let's say this is another computer or a server and there is a person sitting in. You want to talk to your friend. You know his IP address. He is from the same company. You know his IP address. There is another friend. You know his IP address. Everybody are in 111 network only. I know his IP address. But would you know what is the network interface card address of these computers? Would you get to know? No. Right? It is difficult for every machine to know what is the destination MAC address. So let's say there is another computer connected here. 1.1.1.3 and MAC address CC of this network interface card. Person is sitting here. Maybe one of our friends. I know his IP address, but I don't know what is the MAC address of the network interface card here. That is why address resolution protocol is used. Because if I want to reach a certain destination, I would not know what is the network interface card address. Why do I need his network interface card address? Because I have to fill it in the layer 2 header. This computer has to fill that address in the layer 2 header. What is the destination MAC address? It has to fill here. That is why ARP is used. What does ARP do? ARP actually finds what is the network interface card. This guy will know my network interface card address is BB because he will go inside his own computer. He can check my network interface card. What is my network interface card? He will get to know it is BB. But person sitting here will not know that his address is BB. So what does ARP do? Right? Now, we have seen this. Let's write down the scenario again. This is the computer which generated this data. It wants to go to 1112. So source IP, destination IP on the layer 3 field is written. This computer knows only source MAC address. It knows about its own MAC address. So source MAC address field is entered. Data is ready to go, but I don't know the destination. What does the computer do? The computer will check its own ARP table. There will be something called as ARP table inside every layer 3 device. ARP table initially will have its own IP address with its own MAC address. If I check on this computer, how to check the ARP table? Simple. Go to command prompt and say ARP-A. It will have its own MAC address, its own IP address initially. It doesn't know what is the MAC address of 1112. It will not know what is the MAC address of 1112. At that time, what this computer will do? It will call the protocol. Which protocol? ARP protocol. Where will the ARP protocol be? It will be inside this computer only. It will take the help of ARP protocol. This computer will say, hey, ARP, can you help me to resolve or get me the MAC address of 1112? Then the ARP protocol will immediately pitch in. It will say, this data packet is there, which you want to send to the destination. Hold it. Don't send it. I know you can't send it because there is no information on layer 2 destination field. So hold that for a minute. I will create my own packet and I will start my process and I will get you the destination's MAC address. Now the thing is, how does ARP work? What does ARP do? to get the MAC address of this destination. We are going to see that, right? Now, ARP, what it will do is, it will generate its own packet. It will say, this ARP is coming from 1111. It wants to go to 1112, and the source, the machine that is generating, machine that is interested, has a MAC address of AA, and instead of putting any data in the data field, it will say, what is the MAC address of 1112? And here it will say FF. What is FF? I told you yesterday or in the previous session. What is this address FF, or which is written also as FF, 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 all Fs? What is this all Fs? It is known as, anybody has any idea? Broadcast MAC address. Does anybody have any idea what is a broadcast MAC address? Even if it is wrong, you can answer me, not a problem. If you have any idea, you can let me know. No? Nobody knows? Okay. Now, whenever we use something called as broadcast MAC address, then let's say we send this packet, right? In the layer 3, we said, I am the sender, and in the layer 3 destination field, I want to know his MAC address. And in the source MAC address, I have written this machine's name. In the destination MAC address, I am not writing this guy's MAC address because I don't know. Instead of that, I am writing FF, means go to everybody, broadcast MAC address, send it to everybody. In the data field, I am not writing 1010. ARP is not writing 1010. It is inquiring what is the MAC address of 1112. And this particular packet is sent to the switch. Right? This particular packet, that is this one I'm talking about. This is sent to the switch. Now, when this packet is sent to the switch, you know what is the first thing that the switch will look at? Any idea? Nobody knows? The switch will look at source MAC address first. There is a packet coming to me. What is the source MAC address of it? There is a packet coming to me on port number 1. What is the source MAC address? AA. So, in the MAC address table, the switch will store port number 1 has somebody connected with the address of AA. Now, why is switch looking into this field? Only the layer 2 header? Because switch is a layer 2 device. It cannot read this header. This is a layer 3 header. Only routers can read it, or above routers, firewalls, computers, they can read it. But layer 2 device like switch can only read layer 2 header. So it will see first who is the source, and it will make a note of the source in this one. Then it will see who is the destination. FF. The switch will understand anything with all Fs is nothing but a broadcast address. So I have to send this information out of every port. If I have 8 ports, I will send it out of all 7 ports, because I will not send the information back to the same port which I have received it. I'll send it to all the rest of the 7 ports. So the information will go here, the information will go here. Because the switch broadcasted to every other port. Now, focus here. This guy will get that information. Which one? This one. First, he will read this information was sent to FF. Okay, this computer will get the information, this computer will read. This information was sent to somebody called as, or somebody who has MAC address of FF. But MAC address FF is a broadcast address. It will not be assigned to any network interface cards. It is not a one-to-one IP address or one-to-one MAC address. It is a broadcast MAC address. It can't be assigned to anybody. So this packet is sent for everybody. You will understand that this packet is sent for everybody. Okay, no worries. Let me see the layer 3 header. In the layer 3 header, he will see that this packet was sent to 1112. But his IP address is 1113. So he will discard this entire thing. He will not respond anything to this packet. He will just discard the packet. Discard means just like how we throw in the dustbin. Leave it. I'm not taking it. I'm not processing it. I'll not use my brain or respond, talk back on this information. So this PC will discard the packet. Now this PC, first he will check. Where was this sent to? Okay, it was sent to everybody. Broadcast MAC address. And here, it was sent to... Excuse me, guys. It was sent to somebody called as 1112. Who is 1112? Okay, it is me. What do they want? What is the MAC address of 1112? Then you will understand somebody is looking for my MAC address. This packet is called as ARP request packet. Now this guy saw that this packet was to him and somebody is looking for my MAC address. Then he will generate his own packet. He wants to respond, right? He wants to respond to the sender. But before that, even this guy will have an ARP table. Do you agree? I told you every layer 3 devices will have an ARP table, right? He will have an ARP table for himself. In his ARP table, he will have his own IP address and his own MAC address. Now, he got this packet from 1111 and he can see that 1111 is associated with this MAC address. Okay, the computer 1111 has a MAC address of AA. He will understand. So he will update his MAC address table. The computer 1111 has a MAC address of AA. He will fill his ARP table. Now he will generate a response. Let me generate a response. My MAC is BB. This is the response he generated. Now, after generating that response, he has to add layer 2 header. After the layer 1, which is the information, he has to add a layer 2 header. In the layer 2 header, he has to add his MAC address in the source MAC address field. So source MAC address field is BB. Now he has to add the destination MAC address. What is the destination MAC address? He wants to reply to whom? 1111, who was the previous sender. What is 1111's MAC address? AA. He has already updated his MAC address table. So he'll say AA. Then he has to add a layer 3 header. In the layer 3 header, he is the sender. So he'll be in the source 1112. Destination is 111. Now this packet will go to the switch. The switch will see that somebody is coming to port number 2. Who is that? It can only read layer 2 header, remember. It will see the source of the layer 2 header. Okay, the person who is coming to my port number 2 has an address of BB. So it will map it in the MAC address table. Then where he wants to go, it will check the destination. This switch will check the destination. He wants to go to AA. Let me check my MAC address table. Do I have an entry for AA? First line first, second line second. Like that it will search. Okay, AA is present on port number 1. So I will forward this information on port number 1. So the information out of port number 1 will go to this computer. Now this computer will read that information which is coming in. It will read that information. Some information is coming to me. It was sent to AA. Okay, that is my MAC address. And it was sent to 1.1.1.1. That is me. Okay, let's see what is inside. My MAC address is BB. Who is telling that? 1112 is telling that his MAC address is BB. Okay, so let me update my ARP table. 1112 has a MAC address of BB. Now this packet is called as ARP response packet. Now see, through the ARP protocol, we have OR. The destination's MAC address is achieved, is gotten. Now what it does, previously, if you see that there was a data packet which was on hold. Why? Because it did not know the destination, that is 1112's MAC address. Now we have 1112's MAC address. It will put the MAC address inside this data packet and then send the actual data towards the switch. Now what the switch will do? It does not need to learn any MAC address. Actual data will now go to the switch port 1. Actual data is what? This one. From 1112, the switch will read where is it coming from. It is coming from AA, port number is 1. It is already updated. I don't need to update again. Okay, what is the destination of this packet? BB. It wants to go to BB. Okay, let me check my MAC address table. BB is connected to port 2. So I will send that data packet on port number 2. As simple as that. After learning the MAC address through the ARP protocol, now we are able to gain the MAC address of the destination and send the data from one point to the other. So the summary is ARP protocol. What is ARP used for? ARP is used to resolve IP address to MAC address. What do you mean by this? Means we will have the IP address of the destination, but we will not have the MAC address. At that time, we will use protocol called as ARP, which is inbuilt in every layer 3 device. We will call that, this layer 3 device will call the ARP, which is inbuilt inside this. That protocol is inbuilt inside this computer. It will call that ARP protocol to get the MAC address of the destination. So we have the IP address of the destination, but we don't have the MAC address of the destination. So we will use ARP protocol for that. So even in the interviews, if they ask you, what is ARP? ARP is used to resolve the IP address to MAC address. So they might ask you in a different way. What in ARP, before initiating an ARP process, what is the information you have and what is the information you don't have? You can straight away tell, we will have the IP address of the destination, but we will not have the MAC address of the destination. That is the reason we use ARP protocol. Does that make sense? Any questions, any confusions? You can let me know if there are any doubts. Any simplest of simple doubts also you can let me know. Not a problem.
Hello, sir.
Yes, Ajay.
Sir, ARP is a reserve. There is IP address to convert MAC address.
It uses IP address to find out the MAC address. That is correct.
Yes. Sir, RA
Reverse R.
RA reverse R. मतलब
Yes. We will
मतलब MAC
discuss
address.
that also. Yes, definitely. We will discuss about the reverse ARP also. Right?
Oh,
So usually, you know what happens? First, we will actually find out. Now you understood the concept of ARP. Here we know what is destination IP address. We want to know its MAC address. That is why we used ARP. Now, if you want to see what is reverse ARP, this computer, let's say, if it does not know its own IP address, then it will do or initiate a reverse ARP to find out its own IP address. We will discuss about this in the further classes. But ARP concept is clear, right? Ajay?
all right, sir.
Awesome. Okay. All right. So yeah, that was what was planned for this session. If any doubts, we still have 10 minutes of time. You can ask any of the doubts that you have. If there is none, then we can wind it up. Go ahead, guys. You have 10 minutes. You can ask me anything.
Now, when can we access to the lab?
The labs?
Yes.
Yeah, I think once you enroll to the classes, maybe they will immediately have some procedure, after which you will be having the lab access once you are enrolled to it.
Yeah, I read it. How long?
Already
on the
did?
ETA? Yeah, on the ETA.
Yeah, sure. So I think Anurag sir can help you on that. So he'll advise you on that.
Okay. Other question is what days are classes? I mean, Monday to Thursday?
That's right. It will be on Monday to Thursday, 7 p.m. 7 p.m.
Okay.
IST.
All right. Thank you.
Thank you. So tomorrow there won't be any session. We will start with the regular classes from Monday onwards.
Sir, there
I
is
think.
ARP.
Sorry, go ahead.
Sir, Ajay,
Go ahead, Ajay. Yes.
sir, ARP table is IP address to convert MAC address, but there is packet so broadcast.
So
मतलब
ARP table means it is a mapping of IP address to the MAC address. MAC address table is nothing but mapping of port number of the switch to the connected MAC address. मतलब जो भी लेयर 3 डिवाइस है वो सब ARP टेबल मेंटेन करते हैं. All the switches they maintain MAC address table. Switch is a layer 2 device.
Okay, sir.
All right. Right, guys. So I think you guys have no other doubts, so we can wind it up for the day. But if you have any confusions, you can reach out to Gwyneth or me. Anytime you can write it down in a notepad, all the doubts that you have, and let me know once we come back to the class. You don't need to, even if it is the simplest doubts, you don't need to worry about it. You can have it in a piece of paper or notepad. Either you can ask it out in the class or after the class. Okay. Having said that, that's all for today, guys. Thank you for your time. Thanks for joining. Have a good rest of the day. Thank you, Anurag sir.